Hi guys, welcome to the Pepcoding. In this video, we are going to solve max chunks to make array sorted 2. So in the previous question, we have already done the max chunks to make array sorted. That was the first part, and this is the second part. In that question, we have given an array with the values 0 to array dot length minus 1, which was a permutation from 0 to array dot length minus 1. But in this question, we have integers in that array, and these integers can be not distinct, not necessarily distinct, and we need to split the array into some number of chunks as we have done in the first part, and we need to if we sort the individual chunks, we can get the sorted array result. And in this question, we also need to return the max chunks to make array sort. So the difference between the first part and second part is the difference of the element. In the first part, we have the element from 0 to array dot length minus 1. In this, we have some distinct integers like 30, 10, 20, 40, 60. This is a example. So in the first part, we have used chaining technique to solve the problem. In this question, we are also going to use this technique. So here I'm going to use two arrays. The first array will be the L max of the array we have given, and the second array will be R min of the given array. Why we are doing this? In the previous question in part 1, we do know at each element, if this is 2 3 2 0 1, this 3 shows that it have range from 3, this 3 that is at 0 index to the 3. So for finding the range of the elements, we are going to use this Lmax and Rmin in this question. That's why we are going to find the Lmax and Rmin of the array. So let's make the array. I'm going to make this array by the size plus 1 of the given array. For the last element, to compare the Rmin and the Lmax of the elements. So here 1, 2, 3, 4, 5, 6, 7 and 8. 1, 2, 3, 4, 5, 6, 7 and 8. Now this is index 0, 1, 2, 3, 4, 5, 6, 7, 8. This is index 0, 1, 2, 3, 4, 5, 6, 7 and 8. Now let's find the Lmax of the given array. So for finding the Lmax, we are going to start from 0 index. So here at the first index, that is 0 index, we have 30. So the Lmax of 30 is left max. Left max is, there is no element in left, so 30 will be the left max till that position. Now we are at index 1. Here the element is 10, the left max is 30. At index 2, left max is 30. At index 3, the left max is 40. At index 4, the left max is 60. Index 5, 60. Index 6, the left max is 75. Index 7, the left max is 75. Index 8, 75. Now finding the R min, we are going to iterate from the last index. So here in the last index, we have element from 0 to 7, and we are making 0 to 8 of R min array. So in the last, I'm going to save positive infinity value. Now the right min of 70 of index 7, the 70 right min is 70. At index 6, the right min is 70. At index 5, the right min is 50. At index 4, the right min is 50. At index 3, the right min is 40. At index 2, right min is 20. At index 1, right min is 10. At index 0, the right min is 10. So we are going to use these values to find the range of the elements, how far it can go to make the chunks partition. So here, if we are at this position, if we are at this position, this means from 0 to 4, this is the L max value. This means from 0 to 4, that is I, max value is L max at I. We can see the maximum value from 0 to 4 is 60. And here, from the same index, the right min, that is the minimum value, is 50. This means from this index, we are checking index at 4. So this is, we are at 4 here and here. So here we can see the maximum value, the minimum value from I to array dot length, that is I to array dot length. The minimum value is, we can get the minimum value at rmin at I. So we will use this to find the range of each element till how far it go to make the chunks. Now if we are at this, that is at the index 0, if we are at this, the maximum value is 30, the right minimum, how far it can go in the right minimum is, we will check the next index of the rmin. If we are at 0, we will check for 0 plus 1, that is 1. So here we can see 10. 10 is smaller than 30. This means this 30 can go to the next index. Its range is from 0 to 1 now. Now here the maximum is 30 and r min, that is I plus 1, we are at 1. 1 plus 1 is 2. Here this is 20, which is also smaller. This means this 30 have range, it can go to the second index also. Now at this point, if we check at index plus 1, we are at 2, we will check for index plus 1 in the right min, this is 40. Here we can see this is larger than our left max. This means this 30 can go till the second index. This 30 can go till the second index because the right minimum from that position is greater than the 30. So here we can do a partition. We will increase the number of chunks. At the starting it was 0, now it is 1. Now we are at 40. Now rmin at index 4. This is 50, which is greater than 40. This means the right min, the range of 40 is at the 3 index only, at the third index only. This means we can also make a partition again from here. The number of chunks will be increased by 1. Now we are at 60. At index 5 in the rmin, this is 50, which is smaller than 60. This means the left max at 4 can go to the next index also. Now we are at 5th index in the L max. rmin at 6th index is 70, which is greater than 60. This means the range of 60 is till 4 to 5 index, 4 to 5th index. This means we can make a partition here and this will be increased by 1. Now we are at 75. We are at 75. The next value is 17 rmin. This means the range of 75 can go to the next index also. Now we are at 75 again at the 7th index. Here it will check for the next index, which is 8, which is greater. This means we need to make a partition here also and increase the number of count. Now for the last element, we don't need this because we have only element from 0 to 7. So here we can get the number of chunks which are 4, where this is the first chunk, this is the second chunk, this is the third chunk, this is the fourth chunk. And if we sort them, we can get the sorted result. Here we can see the first chunk is here, second chunk is here, third is here, then fourth, this is fourth. So what will be the condition? Condition was when we are increasing the number of chunks. When L max at I is smaller or equal to R min at I. This means we can increase the number of chunks. We can increase the number of chunks here at this condition. And the steps to follow is, first we need to find the L max of the array. Second is we need to find the R min of the array. And the third is we need to increase the count of chunks, increase chunks by 1. This is the 3 steps. But here we can do this if we find the L max and R min. We need 2 arrays, but we are traversing to the array from 0 to the length. This means we can generate our L max by that iteration, and we just need to find the R min first. So here I am going to generate the L max while we were traversing to the array. So the steps are going to change. So the step will be, we will find the R max of the array. Second will be we will generate L max while traversing to the array, and the third is we will increase the number of chunks when L max is smaller than or equal to R min. This is R min. This is R min at I. We need to find the R min of the array, generate the L max while traversing to the array, and increase the chunks when L max is less than or equal to R min. So let's code this. First we need the R min of size. Let's save the size in n array dot size. So here I'm going to make the size n plus 1. We need a one more index for the infinity, for saving the infinity, for the last element of L max. To find that, it will be here we need a chunk also to increase. Now at R min n we need a maximum value, so I'm going to use int val is equal to int of 1e9. Now at R min n I'm going to save the max value. Now for R min we need to iterate from the last index of the array. So we are going to iterate from the last index. I is equal to n minus 1, I is greater than or equal to 0, I minus minus. Here I am going to find the minimum of value and the array at I. The minimum value will be saved at R min at I. So this will give us the R minimum array. Now we need the L max. So L max we are going to generate. I'm going to initialize it by a minimum value minus int of 1e9. Now I'm going to start the iteration at the array. On the array we have already the size n I plus plus. Now here I'm going to find the L max of L max comma array at I, and we will check if L max is smaller than or equal to R min of I. This means we need to increase the chunks. Here I'm going to make a chunk variable in slash by 0, and at the end we need to return the chunks. So we have find the size, we have find the armin of the array, and then we are generating, here we are generating the Lmax, that is left maximum, and here we are increasing the number of chunks. So let's run this. So it is working but giving a wrong answer. We have done something wrong in this. Let's find. So here, when we need to increase the count, we are checking when we are at 2, we were checking for index plus 1. This means here for r min, when Lmax is less than or equal to r min of I plus 1, that is the next value of the I in the Lmax. So this means we need to increase, we need to check for the next index of the r min. So let's run this now. Now it is giving the perfect answer. Let's submit this. So all the test cases are passed. So the mistake was we were checking when we were at 6, we were checking for the index 7. When we were at 0, we were checking for index 1. When we were at 4, we were checking for index 5. That means if we are at the position 4, we need to check the r minimum. So r minimum will be at the next index. This will give us the r minimum, this part. So that was the silly mistake. And now this was the condition when we need to increase the number of chunks. So hope you understand this concept. We will see you in the next video. Thank you.